Ladies and gentlemen, welcome to the webinar about assignment methods in PTV Visum. My name is Johannes Steich. I'm working for PTV Product Management and Services at PTV in Karlsruhe. This is the second webinar of our public transport webinar series. The first one was about public transport supply. Today we will focus on the demand side. The agenda for today is, after a short introduction, I will talk about demand and sources for public transport demand. Thereafter, and the focus of this webinar will be the 3 assignment methods which are available in PTV Visum for public transport assignments. And before a summary and outlook, I will speak about the capacity restraint assignment, which is a special assignment method within PTV Visum. Many of you already have attended last week's webinar, so I will go very fast through the introduction. For those which are new to PTV or PTV Visum, just a few words about PTV Visum. PTV Visum is a multimodal transportation planning tool. We will focus on public transport in this webinar series, and we want to present you PTV Visum as a comprehensive public transport tool which integrates into your system, which can be a shared platform for different users. It could be transport association and operators, also city governments. And as I've shown you last week, due to a very fast model set up by using OpenStreetMap data, by using Google Transit data, you have a high efficiency in working with Visum. At the moment, we have a long list of public transport customers. On this slide, just a few of them, ranging from Deutsche Bahn, German Railway, over city governments, and also metro operators. As I said, today's webinar is focusing on the demand. Demand is the first question: what is actually demand in terms of public transport planning? So if we look at the mobility of persons, we see that there is a classical 4-step model. The first one is a trip generation. So people decide that they want to make a trip, for example, to go shopping. The second level is then the question of trip distribution or destination choice. So which of the different shops should I choose? The third step is then the mode choice. You can walk, you can use public transport, you can take the bike. And the fourth step is the assignment, which means which route, which connection do I choose to my destination. The result of the first 3 steps is actually what we call the demand, which is in Visum and metrics per mode. So one matrix, for example, for public transport, but it also can be several matrices for different time intervals. And the 4th step is then the assignment. There are different sources for public transport demand. One source could be a demand model. These demand models can range from very simple demand models to very complex. So it can be on the one hand only looking at public transport, but it also can be a multimodal demand model considering all modes of transport. Another source can be passenger surveys and counts, and also e-ticketing. Both of those will be discussed more in detail in the 5th webinar when we talk about e-ticketing and passenger surveys. For this webinar, we assume that there is demand already defined. So it's not focused on this webinar to speak about demand model. So we assume we have a matrix from one of the different sources. Let's look how this is stored in Visum. So I have an example network here. What you can see in the network is that we have different zones. So this is the aggregation level we use in Visum. Visum as a macroscopic tool needs to aggregate demand into different zones. And we can see here that we have zones of different types. So in the suburbs, the zones are greater than maybe downtown, where the zones are smaller. For these zones, we have then can have demand matrices. So in our example, we have only one matrix for public transport. And if we open this matrix, we can see that this is a matrix from zone and to zone. And for each of those, we have one value in the matrix. I will put this window next to the network window, and then we can see a nice feature of Visum, which is synchronization. So if I click on one value in the matrix, I can see in the network window the from zone and the to zone, which makes it easier for me to work with matrices. Also, a simplification for working with matrices are the graphic parameters. So what we can do is we can open a predefined graphic parameter set, and then we see a classification. So for example, those with high demand are shown in green, and those OD pairs with low demand are shown with red color. That makes it easier, for example, to identify important OD pairs. For this, we also can use a list view. We can change the view of the matrix into a list view and then can arrange this according to the values, which again makes it easier for us to identify the important OD pairs and which are interesting to have a closer look at them. But of course, we also can see this directly in the network. So we have in the network a graphic layer which we call OD pairs. This shows us graphically from where to where the people want to go. If I'm activating this, we can see that we have major public transport demand in the south and in the west of the network. The reasons for this are probably the universities which are located in this part. If we want to connect the demand to the public transport demand segment, we have to do this under demand and demand data. Here we, on the one hand, can assign the matrix to the public transport demand segment. This is important if we, for example, have different demand segments, one for students, one for employees, one for pupils. In this case, we just have one matrix, which we assign to public transport. And then we can define a time series for this demand. And in this time series, we can define, for example, the morning peak or the evening peak. Once we have done this, we are ready for the assignment. If we go closer into this, we first, for those which are not familiar to transportation planning, we shortly should talk about what is actually an assignment. So an assignment is about finding connections from an origin to a destination. So in our case, here in this network, from A village to X city. So in our example, we have a bus connection from A via B to X with, in our example, 4 departures and with 3 departures, and there's also a train which goes from the station to the destination. From this, we can easily define that there are 5 possible connections, some with transfers and other without transfers. We also can look at this example directly in Visum. So we see the same network in Visum, and now we can have a different view on this one also by looking not only at the network but also looking at the timetable editor. In this timetable editor, we can see the bus rides in green and the train rides with a black and white line. we can see, as it was possible to identify from the timetable, that we can, from the first bus, we can change to the train. From the second bus, changing to the train is not attractive because we would have to wait very long. And from the third one, it's again quite attractive to change to the train because we arrive earlier than the bus. If we run an assignment here and look at the results in the network view, we can see that from 90 people departing from A, roughly 50 or 49 in our example take the direct bus, and 40 of them change to the train. Of course, this is not only stored on this aggregated view, we also can look at this in the timetable by changing the graphic parameters, and then we can see that, for example, from 39 people starting with the first bus, 25 take the train and 14 stay on the bus, which is a longer trip but less hassle because you don't have to transfer. And we can see that, for example, for the last bus, this share is a bit different here. Roughly 50% stay on the bus and 50% change to the train. How many change to the train and how much penalty a transfer is something we can set in the assignment procedure. From those assignment procedures, we have in total 3 in Visum. The first and most simplest one is the transport system-based assignment. Then we have the Headway-based, or also known as frequency-based assignment. And finally, the timetable or schedule-based assignment. All of them, for all of them, there are good reasons to use them. So there's no general rule which is the best one. But what is clear from the transport systems-based assignment up to the timetable-based assignment, the level of detail in the model is increasing. And of course, this requires also more modeling effort. Let's see what are the main purposes of the 3 different assignment methods. The first one, the transport system-based assignment. This requires only very little modeling effort because we just have to define the network and the traveling times in the network. But we don't need to define lines or a timetable. It's only about where is it allowed to use public transport, so where is bus allowed and where is train allowed. This can be interesting for sketch level network design, so to get a rough idea from where to where and on which route people want to travel. On the other hand, the most detailed one is a timetable-based assignment. Here we assume that travelers know the network, including all lines and also including the full timetable. And they check the timetable before they start their trip, and they assume punctual services. This timetable-based assignment is then interesting if we want to do detailed analysis of transfers and also if we want to model complex timetables with additional services, maybe in the morning, going to the schools and many other different complex services. In between those, we have the Headway-based assignment. Here we assume that travelers know the network, the line frequency and running time, but not the actual departure times. So this is not only an assumption that travelers do not know it. In some countries it's quite usual just to not to have actual departure times in the timetable. Here we only find information such as the frequency in different time intervals. This assignment method is justified if the headways are maybe less than 30 minutes. If the headways are too much longer, then we come to a situation where the transfers become more and more important. And in these cases, it's good to have detailed knowledge about the transfers. We will see an example for the difference later on. First, let's do a bit hands-on example on the transport system-based assignment. As I said, the main input for this are only information on the links. So the information on if a link is allowed for certain transport systems. So I was choosing one link here, and we can see this link is allowed for the public transport system bus. And we also can see certain travel times which are assumed for this link. This is all information which is required for the public transportation system-based assignment. So no information about real run times, maybe dwell times at the stops, no information about the lines. If we run such an assignment, we only have very little parameters, which I'm going to skip now. I'm running this assignment. It takes just 1 or 2 seconds. And what we can see now in the network view, if we turn on the link bars, we can see the volumes of this transportation system-based assignment. What we can see, and what probably is a bit strange, is that we have very high demand on the east-west direction on the buses, and very low demand here in the south for the railway. We later see reasons for this. If we go back to our assignment methods, this was the first one, the transportation system-based assignment. Now we go to the timetable-based, the more detailed one. This consists of 3 steps. The first one is the connection search. The second one is to define the connection impedance. And the third one is about the connection choice. For the search, Visum is using very similar algorithms as we know it from timetable searches, maybe on the internet. So we want, in this example, to go from Karlsruhe to Salzburg, and this timetable service finds different connections. And the same is happening in Visum. Here we are using for the connection search and branch and bound algorithm, which combines different path legs. So, for example, from Karlsruhe to Stuttgart, from Stuttgart to Munich, and then from Munich to Salzburg. Different combinations are found with the branch and bound algorithm, which then gives us the choice set for the destination choice. Let's see how this can be defined in Visum. In Visum, if we change to the timetable-based assignment, we have a couple of parameters. So the first important one is about the search. So here the parameters for the branch and bound algorithm can be set. So of course you can, if you have a large network, you can assume that there are many ways, for example, to go from Hamburg to Munich. So if you do not restrict the search, you would even find connections going via Madrid. So having a large detour. That's why we can limit here the choice or the connection search to a reasonable level. So we can delete already during the branch and bound search. We can delete different connections if they are too unattractive. Once we have found our choice set, we have to give each of the connection an impedance. So usually travelers do not decide only on travel times. Also, things that can be important are the number of transfers. So we can put a penalty here for the number of transfers. And of course, what also is interesting is the fare. So if we have modeled the fare system, we have a closer look at this at the next webinar. It's interesting to include this into the assignment so that people try to avoid expensive connections. To set the parameters here, it's good to look at the literature or to make a passenger survey to get an idea how important different parts of the journey are for the passengers. The last step is then the choice. So we have a couple of different connections. Now it's a question, how does the passenger choose the the connection. We have different choice models here, which are in all details are described in our manuals. If we run the assignment, this now takes it longer because of the connection search being much more complex than in a very simple transportation system-based assignment. Once we look at results, we will discover large differences in the volumes. One difference, train higher volumes. Main reasons for this is that in the transport system assignment we were not looking at the stops and the stop times. And then, of course, the downtown bus is very attractive compared to the railway, which has less stops. Of course, we could have set the travel times differently in order to reflect this also in the transport system assignment. Once we have run the assignment, we can run different analyses. One is what we call a flow bundle analysis. Such flow bundle analysis analyzes the passengers which are on a specific link or which are starting from a specific zone. So we can say we want to analyze the volumes going over this link. If we run this, we then can see from where to where those people on this link are traveling. So on this link on the bridge, we have mostly travels from the eastern to the western part of the city. This can be interesting in order to analyze the demand more in detail. Also important is to look, and interesting is to look at the assignment statistics. So this gives us very aggregated information about the assignment. So we have indicators such as the mean journey time, we have the mean in-vehicle time, mean transfer time, and also often important as the mean number of transfers in order to analyze the quality of our network. Of course, we also can look at the results in lists. So we have seen this list already last week, filled with the parameter indicators such as service kilometer. Now, after running the assignment, we also can see information on passenger kilometers and the number of passenger trips on each bus service. So this is interesting data in order to analyze our network. So of course we can further process this and can see average demand on each bus service. One graphical view, what we have is the so-called transfer display of regular services. So if we look, for example, at Halle main station, we can see in this view all arriving and departing services. We can see the demand on these services. And finally, and very important, we can also see the demand on the transfer relations. So this is very important in order to analyze whether we have to improve the connections in our network. But of course, this requires a detailed timetable. If I'm only using the timetable-based, the frequency-based assignment, then we don't have all this information available, and we are losing this kind of information also during the assignment. So it's not that easy for the frequency-based assignment to evaluate transfers. We can see this in a very little example. We have here an example network with different lines showing by different colors. We can see the run times between the stops. And if we look on this from a we have more or less 4 paths which could be used, 1 direct one and 3 with changing the bus, the line. If we look on this from a timetable-based view, we can see that, for example, the path first with the black line and then changing to the yellow line is not attractive, because it was a 1 hour headway, and we can see that we miss the connection at stop 2. So from a timetable-based view, the fastest connection is to take the green line and then to take the blue line, because with this we have an early arrival, or even better, we take the direct bus service, which is the black line. If we look at this from a headway-based point of view, it's more difficult for us to evaluate which connections are attractive and which are not attractive. Main reason is for this because we do not exactly know how much time it takes for transfers. And this is the main difference between timetable and headway-based assignment. If we want to have a closer look at transfers and transfer times, then we need the timetable-based assignment. In networks having a high frequency, so lots of services where the transfer waiting times are not so relevant, then the headway-based assignment also generates good results. Let's also look at the headway-based assignment. Here we have a number of interesting parameters. During the search, we have the possibility to define coordination of lines. So also an information which we do not have in a headway-based modeling. And we also can define interchange times at certain stops. So if we know for certain stops that our transfer quality is very high, we can insert this manually at these stops, which improves then the quality of the assignment. If we are not using any of this information, then Visum will simply assume random arrivals and departures, and will not have good coordinations between during the transfers. For all assignment methods, we can write a couple of skim matrices. So we can write, for example, journey time matrices, ride time matrices, or transfer wait time matrices, which we then further can analyze using the matrix editor or using the network editor view. Now, in the last step of the agenda, I want to have a quick view at the capacity restraint assignment. This capacity restraint assignment is new in PTV Visum 12.5. Before it was only a script-based solution. Now it's a fully integrated solution in PTV Visum. You can see here a little example network. So we have from A to E, we have demand. This demand is rising and then decreasing again due to the time series. And we can see we have a direct bus from A to E, which is the fastest connection. We have one bus with a detour via C, and we have another bus line from A to B and then one from B to E. If we look at the timetable editor, we can see here the direct bus, which is the slower bus, and we can see the direct bus, which is the faster one. If we run here a normal timetable-based assignment, we will see the results in the network by this view. So all of them are taking the fastest direct bus. If you look at this in the timetable editor view, and if we are adding the volumes here, we can see in the beginning the volumes are roughly 40, rising up to 60, and then going over 100. And this is of course not realistic for a bus service, and because the capacity of a bus may be around 100. In order to reflect this in the assignment, we can use the capacity restraint option within the timetable-based assignment. So we have in the parameter view, we have here the option to use capacity restrictions, and then we have two more tabs where we can define parameters on the capacity restriction. Most important, of course, we have to insert here the capacity of each vehicle journey. And then we can also define a volume delay function which reflects the capacity restraint. And if we then run this assignment again using the capacity restraints, we will see that many people from the direct bus service change to other services. So the maximum demand is here around 102, which is roughly our capacity. We see the same also in the network editor view. Here we have now less demand on the direct red service and also demand on the other services. This capacity restraint assignment is also available for the Headway-based assignment. Here, this is a script solution which you find in the installation folder. So what we have seen today, as we are now coming to the end of this 30 minutes webinar, is that there are different sources for public transport demand. It can come from a model, it can come from surveys. And once we have this demand represented as a matrix or as different matrices for different time intervals, we then have in Visum 3 different assignment methods available, which is the transportation system-based assignment, the Headway-based assignment, or the Timetable-based assignment. Each of these assignment methods has advantages and disadvantages. So if you make a project with Visum, you should look what is your requirement in your project, and then you should choose an appropriate assignment method. Of course, if you do this, you always have to make sure that you use one assignment method throughout your whole project, also for future scenarios. If we have an outlook on the upcoming webinars, where you can get more information on public transport features in PTV Visum. We have next week, on 29th of October, we have fare modeling in Visum. Thereafter, we have a webinar about line blocking and also passenger surveys and e-ticketing. You find all of information and possibility to register on ptvvision.com/put. If you need more information, you can attend our user group meetings. Now we have a series in Asia and Asia Pacific, Hong Kong, Singapore, and Melbourne. End of November we have a user group meeting in Strasbourg, and then next June we have again our large international and German user group meetings in Hamburg and London. You can get more information on ptvvision.com and on our special public transport website, ptvvision.com/put. There you can download a trial version if you want to try out different functionalities. If you're already an existing customer and say, okay, I want to use something which is maybe at the moment not included into my license, just get in contact with us and we can solve this issue for you. If you have installed Visum, it's always good to have a look at the PTV Visum installation folder. Here you find an overview document about the newest features. You find different trainings and tutorials on interesting features, for example, the capacity restraint assignment. With this, I'm coming to the end of the webinar. You now have the possibility to ask questions using the webinar functionality. I will try to answer them as fast as possible. Or you also can send me later an email using my email address johannes.schleich@ptvgroup.com. I hope this webinar was interesting for you, and we hope to see you again in one of our next webinars. Thanks for attending, and goodbye.